Alright, so now we'll now move on to something very simple and very interesting. So today we're going to do successive differentiation or higher derivatives. So what is this same successive differentiation? This is when you have been told to differentiate a function more than once. You find dy over dx again, you find the dy over dx of that function again, just like that. That's what you call successive differentiation. So let's see what we're talking about. So for example, you have been given a function y is equal to function of y, an equation for y. Then when you differentiate it, you find dy over dx. Again, even this same thing, you can still differentiate it. You will have something like this. Again, so what's this? So today we'll talk more about this going up. So this is the 2y over dx squared. This happens when you differentiate dy over dx. Again, when you differentiate the same the 2y over dx squared, you will have the 3y over dx cubic. Again, if you differentiate more, you have the ny over the x power n. So let's look at some examples on how we can do this. So an example says differentiate the following equations in their lowest terms. So let's look at number one. Number one says y is equal to 3x squared minus 4x minus 6. So let's differentiate this one in its lowest term. So how are we going to do it? We'll say dy over dx is equal to differentiation of 3x squared. You will have 2 times 2 is 6x. Since you have the 2 here, 2 minus 1 is 1 here, minus 4x. So if you have 4x, you only remain with a 4 here. Then again, differentiating this one, you will have the 2y over the x squared, which is equal to, since you have a 6x here, you only have a 6. Differentiation of a constant, it's 0. So here it's only a 6. So even this 6 again, you can differentiate it. So we have the 3y over the x cubic is equal to differentiation of 6. 6 is a constant, so you have a 0 here. It means you are done. As simple as that. Then we go to example number 2. So we have been told to differentiate this function. So to differentiate it, you will say dy over the x is equal to, so differentiation of this is 5 times negative 5 is negative 25x. 5 minus 1 is 4. Minus 4 times 4, 16x. You add the 4, you will remain with a 3. Negative 3 times 3 is 9x squared minus 2 times 2, 4x. Here you add an x, so where you have x, you remain with only negative 1. Then even this same function, you can differentiate it. So if you want to differentiate further, you can even do d over the x of dy over dx. That's the formula you can write. So if you want, you can even just write it direct like this, is equal to, so since here you have a 4 here, 4 times 25 is negative 100 x to the power 3 minus 3 times 16, 3 times 6, 8, 3 times 1, it's 3, plus 1, 48, x squared minus 2 times 9, it's 18, x, negative 4x will become negative 4, negative 1, it's 0, you end 0. Again, since here it's dy squared, here it was squared, you go to the 3y over the x cubic is equal to, so here you have negative 100. Negative 100 times 3 is negative 300 x squared minus 48 times 2 The answer is 96. X minus 18. We can differentiate further. So let's do one last one. So the 4y over the x power 4 is equal to, what's 2 times negative 300? It's negative 600 x minus differentiation of 96x, it's 96. Here 0. The 5y over the x power 5 is equal to, since here you have negative 600x, since x has a power 1, it will only remain with negative 600 here. Here becomes 0. The 6y over the x power 6 is equal to 0. You are done. That's what we call successive differentiation. So there's nothing tough about this. You can just be doing further and further more. Then let's do another example on higher derivative, which this is a more practical example. So the question says, given that y is equal to 2x exponential negative 3x, show that the 2y over the x squared plus 6 dy over the x plus 9y is equal to 0. So what are we going to start with? So first of all, we have our y, which is equal to 2x exponential negative 3x. So now we have been told, we have in the question, you have to show the 2 that it's equal to the 2y over the x squared plus 6 dy over dx plus 9y is equal to 0. So we have to find dy over dx and also the 2y over the x squared. So let's first find dy over dx. So dy over dx, we are differentiating this one. So as you can see here, this is the product law, because we have 2x which is multiplied by exponential. So the formula for the product law, we said, is equal to u complement v plus v complement u. So then we say let u equal to 2x, v equal to exponential negative 3x. Then our u complement will be 2, and our v complement will be negative 3 exponential negative 3x. Then we now begin by replacing in the formula. So dy over dx is equal to, our u complement is 2 multiplied by, our v is exponential negative 3x plus our v complement is negative 3 exponential negative 3x multiplied by 2x. So 2 by this is 2 exponential negative 3x. Positive times negative, it's negative. 2 times 3, it's 6x exponential negative 3x. That's our dy over dx. Then now we have to find our d2y over d. So d2y over the x squared. So we have to now differentiate this same function we have here. So how are we going to differentiate it? So let's just break it down first of all. So let's find first d over dx of 2 exponential negative 3x. So when you differentiate this one, you will have negative 6 exponential negative 3x. Then now differentiation of, so d of dx of 6 negative 6x exponential negative 3x. The formula we're going to use, since again you have negative 6x, this is also the product. So we are using the same formula, u complements v plus v complements u. So we'll say let u equal to negative 6x. So then u complement will be negative 6. Then our v is equal to exponential negative 3x our v complement will be negative 3 exponential negative 3x. Then the 2y over the x squared is equal to since you have said u complement v plus v complement u, so is equal to our u complement negative 6, our v it's exponential negative 3x plus v complement. So what's our v complement? It's negative 3 exponential negative 3x plus d over dx of 2 exponential negative 3x here multiplied by, this is v complement, then our u is negative 6 plus the answer for differentiation of 2 exponential negative 3x we found to be negative 6 exponential negative 3x. So is equal to here. So negative 6 times exponential, here we have negative 6 exponential negative 3x. Positive times negative, it's negative here. 3 exponential, 3 times 6, negative times negative, it's positive. 3 times 6, it's 18. Then x exponential negative 3x. Positive times negative, it's negative 6 exponential negative 3x. As you can see, these two are the same and they're having the same sign, so we are going to add them. So it's equal to, you start with this one, 18x exponential negative 3x. Negative 6 minus 6, we have negative 12 exponential negative 3x. Then now we go back to the question. The question was saying prove that the 2y over the x squared plus 6 dy over the x plus 9y is equal to 0. So now let's just replace what we have where we have to replace them. So our the 2y over the x squared is 18x exponential negative 3x minus 12 exponential negative 3x plus 6. What's the dy over dx? dy over dx we found to be 2 exponential negative 3x minus 6x exponential negative 3x plus 9. What's our y? Our y was our original function, which was 2x exponential negative 3x. So here it's just a matter of multiplying and adding and subtracting. That's all. So here we have 18x exponential negative 3x minus 12 exponential negative 3x plus 6 times 2, it's 12. So here we have 12 exponential negative 3x. 6 times 6, positive 6 times negative 6, it's negative. 6 times 6, it's 36x exponential negative 3x plus 9 times 2, it's 18. So here we have 18x exponential negative 3x. So now let's add and subtract what we have. So here you have 12 and 12, they are the same, so these two they can cancel. Then what else do we have which is the same? So here we have 18 and 18. When we add them, we have 36x exponential negative 3x. We also have negative 36x exponential negative 3x. Since here it's positive, here it's negative, the answer is equal to 0. It means you have proved this because they said the 2y over the x squared plus 6 dy over dx plus 6y is equal to 0. So you have answered the answer to be 0. So it means you have proved it. As simple as that.